Hello, I'm Grant Vavro. This is my presentation on Bode plots. To start, we have magnitude. Magnitude is uh, it's how much difference there is in between the amplitude of your input and your output. So if your magnitude is 5, that means that your output's amplitude is 5 times the amplitude of your input. If we look at the Bode plot, it has magnitude in units of decibels. Here we can see that the definition of the decibel is just 20 times the log of whatever value you want to input. In our case, it's magnitude. What this means is that if we have a magnitude of 0 decibels, we have a regular magnitude of 1, because the log of 1 is 0. What that means is that the input and the output have exactly the same amplitude. As the magnitude in decibels approaches negative infinity, the amplitude approaches 0. This is because the log of negative infinity approaches to 0. And then as the magnitude in decibels gets larger and larger and larger, you'll see exponentially increasing amplitude. The phase is the difference in what's the phase shift between the input and the output. So a phase of 0 means that the input and the output are perfectly in sync. A phase of negative 180 means that when the input is at its maximum, the output will be at its minimum. So a pretty intuitive example of how to read a Bode plot comes in swings. So if we take our input to be the position of the legs and the output to be the position of the swing, which is a simplification of how swinging works, but just, use this as an example. You can imagine that if you sat on the swing and you move your legs really, 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 really quickly, you'll see that you're not really moving anywhere at all. So we see that here on this plot. If we have a high frequency, the magnitude in decibels is going to be very low, which means that we're going to have an amplitude change of about 0. The effect of our input is effectively nothing. Now, if we look at frequency, a low frequency, this is just like if you kicked your legs, one time, that might cause your swing to move up a little bit. But because you're not kicking repeatedly, you're not gonna multiply. You're not really gonna get very high. You'll just go up a little bit and then fall back down. Now, if we look at about whatever this frequency is, this is sort of we can imagine when you are timing your kicks right, you're moving your legs such that you are when you're at a 90-degree shift from the swing, and that way you're always adding momentum to yourself whenever you move your legs. So we can think of this. This sort of makes sense in terms of the phase too. If you have your legs sort of out of phase with the swing, you can get yourself up in the air. And if we look, like, it makes sense here. You have a low frequency, you're going to move exactly with this swing. And if you have a really high frequency, it doesn't really mean anything that it's at negative 180 because your magnitude is 0. So any phase shift with 0 magnitude is irrelevant. And that's it.